Picture a tiger. Tigers are known for their beautiful stripes, which they always keep the same. However, imagine if the tiger's stripes could change their size, position, and colors from time to time. Magical, right? But that's exactly what happens with one titan of our solar system, Jupiter. Why and how? Well, astronomers might just have the answer, so let's see. Jupiter is a huge and fascinating planet. When you're looking at its picture from far away, it's like seeing a beautiful sunrise. Here we have an entire palette, from creamy pale yellows to caramel browns, with even some blue shades. Jupiter is a fascinating place made mostly of hydrogen and helium, just like our sun. However, it didn't gather enough stuff during its formation to become a star. Instead, it became a colossal ball of gas that could fit more than 1,300 Earths inside. Jupiter has these interesting patterns of dark and light clouds that go around the planet in alternating bands like giant stripes. These dark stripes are called belts, and lighter ones are called zones. Actually, it's not unique in this. Earth and Jupiter both have these cool patterns in their atmospheres. It's just that Earth has a few of them, but Jupiter has a lot more. Why are these belts brown and beige? Those can be explained by the combination of hydrogen, helium, and other trace elements in the planet's atmosphere. It's like mixing different colors of paint to create new shades. These belts create beautiful patterns across the planet's surface. Now, because Jupiter has such a massive atmosphere and a weather system similar to Earth's, it experiences some extraordinary storms. So even though these stripes may look calm and peaceful, they're actually part of a wild weather system. It's like a never-ending storm party happening there. These belts and zones move in opposite directions around the planet. The belts go against Jupiter's rotation, like going against the flow, while the zones go with it, joining the dance. And not only do they move in different directions, but they also exist at different heights in the planet's atmosphere. The belts are like regions where things are rising up, like bubbles in a fizzy drink. So the cloud tops in the belts are higher up in the sky compared to the cloud tops in the zones, which are more like sinking areas. So, even though Earth and Jupiter have this similarity, their weather is completely different. It's like comparing apples and oranges. One of the most famous storms on Jupiter is the Great Red Spot. But why is it red? Well, that's a bit of a mystery. Scientists think that the storm sits at a higher altitude than the rest of the atmosphere. This means it gets a stronger dose of sunlight. Imagine standing on a hilltop where the sun shines brighter on you compared to the surroundings. In a similar way, the Great Red Spot gets more radiation from the sun. The storm also contains some special chemicals in its clouds, like ammonia and acetylene. When these chemicals receive that extra radiation, they react in a unique way, giving the storm its distinct red color. It's like a special effect in a cosmic theater. Anyway, the stripes look pretty cool and all. But what's the big mystery around them? Well, you see, one day scientists decided to look at data from deep inside Jupiter, about 30 miles below the surface. And after peeking in Jupiter's secrets, they noticed something strange. When they looked at Jupiter using a special type of light called infrared, the colors of its stripes actually switched around. The light bands that were pale and creamy in normal pictures become dark in the infrared view. The dark bands that were belts before now shined brightly in the infrared. This suggests something interesting. The belts on Jupiter have thinner cloud coverings compared to the zones. It's like the belts are wearing sheer, see-through outfits, while the zones have thicker clouds, like fluffy jackets. So, what we see as dark bands in normal pictures turn out to be bright in the infrared, hinting that these belts have less cloud stuff blocking the light. But here's the most strange part. Every few years, something changes. It's like the weather on Jupiter goes through a wild roller coaster ride. The colors of the belts can change, and sometimes the whole weather pattern becomes a bit crazy for a while. Scientists have been scratching their heads, trying to figure out why this happens. So they've decided to use a special spacecraft called Juno to investigate this. Since 2016, Juno has been gathering a lot of information about Jupiter, like a spy collecting clues. One of the things Juno has been looking at is Jupiter's magnetic field. Just like Earth, Jupiter has a magnetic field. It's like an invisible bubble that surrounds the planet, extending to space. This magnetic field is really important because it protects the planet and everything on it. It acts like a shield against harmful particles from space, like those coming from the sun. But Jupiter's way bigger than us, so his protective shield is much stronger. Magnetic fields are generated by something called a dynamo, which is like a big, swirling, conducting fluid inside the planet. This fluid moves around and rotates, kind of like a dance party happening deep within the planet. So, scientists have been looking at the data collected by Juno over the years and noticed something interesting. Jupiter's magnetic field has its own little motions, kind of like when you see waves in the ocean. Scientists call these motions torsional oscillations, which is just a fancy way of saying wave-like movements. It's like Jupiter is doing its own magnetic dance. Now let's imagine that Jupiter's insides are like a giant pot of boiling soup. Deep within Jupiter, there are slow currents that carry heat upwards, just like a conveyor belt. This heat eventually reaches the upper part where we see the clouds. But here's where things get interesting. Imagine someone starts stirring the soup really fast with a spoon. Those wavy magnetic movements, the torsional oscillations, act just like that spoon. They create a disturbance that messes up the slow currents. Now this disruption has a big impact on Jupiter's weather. It's like turning up the heat in the kitchen and changing the way the soup cooks. The patterns of rising and sinking in the clouds, which we call upwelling and downwelling, get all mixed up. A whirlwind in the soup. Our clever scientists also noticed something special near Jupiter's equator. They discovered a concentrated spot of magnetism called the Great Blue Spot. And guess what? This spot is slowing down, like it's taking a break from its usual fast movement. This suggests that a new type of wavy motion, a new dance, is about to begin. So, to sum it all up, the scientists have come up with a cool idea. These wavy magnetic movements, the torsional oscillations, disrupt the slow currents inside Jupiter, messing up the cloud patterns and causing wild weather. And when the scientists calculated the time it takes for these wave-like motions to happen, they discovered that they match the same time periods when the stripes on Jupiter change. So, in simple terms, the scientists think that these wave-like movements in Jupiter's magnetic field are causing the changes in the stripes on the planet. Pieces of a puzzle are coming together. Scientists are still trying to fully understand why this happens, but it's an exciting step forward in unraveling the mysteries of our vast universe. But there are still some mysteries left to solve. To find more answers, scientists need to keep watching Jupiter closely in the future. By observing how the clouds change, they can check if their theory is correct or if it needs some adjustments. From its massive storms to its colorful belts, Jupiter never fails to amaze us with its cosmic wonders. It may not have ignited as a star, but it shines brightly as a gas giant, captivating us with its size and beauty. So keep your curiosity alive and always reach for the stars.
You're standing in a room full of explosive gas. One spark could cause an explosion so powerful that all the windows and doors would be just blown out with a huge column of fire. And you're holding a match. You need a bigger target than this room. How about the largest room of explosive gas in our entire solar system? Meet Jupiter. It's the 5th planet from the Sun and the largest one in our system. It's 11 times the width of Earth and almost 2.5 times heavier than all the other planets in our solar system combined. If we put Jupiter on the scales, we would need about 317 Earths to balance it. But most importantly, it has a lot of methane in its atmosphere. It's the gas we use in our kitchen or fill up our car with, and it burns just fine. More importantly, there's metallic hydrogen. In its normal state, hydrogen is the lightest element in the universe, but on Jupiter, it's at great pressure, more than 400 million atmospheres. By comparison, on Earth, you feel the pressure of 1 atmosphere. So multiply that by 400 million, and hydrogen is compressed so much that it looks like liquid metal. Metallic hydrogen can be a great fuel. It'll give off 20 times more energy than burning ordinary hydrogen. So you and your match can have great fun out there. Okay, here we go. The first problem is distance. Jupiter is only one planet away from us, but the path is also blocked by the asteroid belt behind Mars. It's full of giant rock debris. On average, each asteroid could be as wide as the distance from Los Angeles to Las Vegas. There's rocks the size of an entire state. And the biggest asteroid of them all is Ceres. It's almost as wide as Alaska. It's even considered a dwarf planet. And this dangerous journey to Jupiter takes about 650 days. That's almost 2 years of boredom inside a spaceship. By comparison, the longest time astronauts have spent aboard a spaceship is 84 days. But we'll let you take your favorite DVD collection and a couple bags of popcorn. At the end of the day, you'll be able to get some sleep after a hard day at work. Fast forward 2 years into the future, and you've arrived at your destination. You're already imagining lighting a match at the surface of Jupiter, exploding it like a balloon. Oh, be careful when you get close to it. Because of Jupiter's great weight, it has a strong gravitational force, about 3 times stronger than back home on Earth. The closer you get to its surface, the weaker you feel, and you can even barely stand on your feet. The maximum weight you can lift here is also 3 times less, and even a match you're holding in your hand already feels heavier. If you try to jump up, you need more effort. Actually, you can't even do that because Jupiter is a gas giant. That means it has no solid surface. Theoretically, the deeper you dive into these clouds, the more pressure you'll feel. Gradually, the clouds and gases thicken and form a kind of liquid. But you don't have to dive that deep. Methane is a light gas, and it's closer to the surface. So, this is the moment of truth. You take a match, you flick it on the box, and nothing happens. Well, let's give it a couple more tries. Second match. Third. Nothing works. Okay, you've got a gas burner in your backpack. You unscrew the valve to maximum, and nothing happens again. Well, that's because it takes 3 components to start the combustion process. The first is fuel. Luckily, there's enough methane and metallic hydrogen on Jupiter to blow up the whole planet in a matter of seconds. The second component is the ignition source. It's the initial force that will start the combustion process. It could be a spark, an electrical discharge, or a match like the one you have in your hand. And the last ingredient is oxygen. Yes, the same oxygen that we breathe. It's just as important to fire as the fuel itself. For an experiment, try lighting a small candle. Now cover it with a glass. You see how the fire keeps burning for a few seconds and then goes out? The fuel is still there, but the fire has used up all the oxygen inside the glass, and the burning process is over. The same thing happens on Jupiter. There just can't be fire, simply because there's no oxygen. And you didn't even have to fly there to find that out. From Earth, we can see hundreds of thousands of little meteorites falling on Jupiter. The asteroid belt next to it is to blame for this. When they hit its atmosphere, they start to burn, and that doesn't instantly blow up the entire planet. But don't be upset. There's still a way to ignite this gas giant planet. All you have to do is trigger a thermonuclear chain reaction on the planet. Then, there'll be an explosion so powerful, it'll be visible from Earth, and it will be like the birth of a new star. To do that, we need to detonate a nuclear reactor, like the ones that give us electricity here on Earth. In fact, we'd have to send everything we have to Jupiter, but even that won't do the trick. Big asteroids, when they hit the planet, cause a much bigger explosion. In 2009, a meteorite the size of 5 soccer fields hit Jupiter. It caused an explosion of 5 billion tons of TNT. This incident left a dark spot the size of the Pacific Ocean. And an even bigger explosion happened there in 1994. After that collision, there was a giant spot on Jupiter, almost the size of our planet. But strong winds and storms quickly began to sweep away the traces of the explosion. After a few weeks, Jupiter looked like normal. The problem is that our attempts to blow up the gas giant took place on the planet's surface. We need to plant a charge the size of the moon deep below. A massive explosion will cause a thermonuclear reaction and cause the metallic hydrogen to detonate. The explosive process is set, and within seconds, Jupiter explodes like a giant balloon. But this spectacle will be the last one that humanity ever sees. The explosion would disturb the stable orbits of Earth and the other planets. The trajectory of Earth around the Sun might change, and we may see the dawn not in the east, but on any other side of the world. When the strong wind from the explosion reaches the Earth, it'll start scraping our atmosphere. Soon, our planet will lose its ozone layer. It was our shield that protected us from solar radiation. In such a situation, we'll have to hide underground for the rest of our lives. But even this can't protect us. Before long, the Earth will be showered with thousands of meteorites. Jupiter was so heavy that it held the asteroid belt in place. Without it, the asteroids would start flying towards us. Earth would feel a constant meteor shower, but there would be no one left on Earth to observe it anymore. Jupiter's explosion can be compared to a supernova. In fact, Jupiter is practically a star. If it were just a little bigger and heavier, it would start to shrink. The intense pressure on the planet's core would start thermonuclear reactions. Eventually, Jupiter will have turned into a brown dwarf, and it would be 50 times heavier than it is now. But because it doesn't have enough weight to do that, Jupiter is sometimes called a failed star. Well, maybe we should visit other gas planets in our solar system and try to light our match there. Saturn. Saturn's atmosphere is similar to Jupiter, but there's no oxygen for combustion there either. So all you have to do is admire the planet's beautiful rings and move on. Well, Uranus and Neptune are much smaller, and they don't have metallic hydrogen, so their explosion wouldn't be as strong. But you still wouldn't be able to ignite them with a match, because there's no atmosphere full of oxygen. But there is one planet where you could light a fire with your match. It's GJ1132b, and it's 39 light-years away. Scientists think it might have oxygen on it, although it's not a gas giant that has combustible gases in its atmosphere. But you can still sit on its rocky ground and make a fire to admire the unusual sunset.
Jupiter's gravity shattered a huge comet. It wasn't enough for the space monster. A real catastrophe happened. The shards didn't fly in different directions. They lined up and rushed towards Jupiter like the rail cars of a train. 21 fragments up to 1 mile in diameter burst through Jupiter's atmosphere. Fireballs at the speed of 37 miles per second bombarded the planet's shell. They heated the space around them to 50,000 degrees Fahrenheit. That's higher than the temperature in the Sun's upper atmosphere and 312 times hotter than you need to boil an egg. Well, I'm not hungry anymore. The impact was like from a rock falling into a pond. The meteorite fragments formed giant plumes on the surface of Jupiter. Substances from its lower atmosphere rushed upwards. The process generated a tremendous amount of energy. Overheated streams of fire shot into the stratosphere. The monsters left behind them glowing plumes 1,900 miles long. That's greater than the distance between New York and Texas. Dark bruises appeared at the side of the blows. They were about the size of the Earth. Comet Shoemaker-Levy 9 was the name of the violator of Jupiter's boundaries. The collision of celestial bodies happened in July 1994. It was a scientific sensation. For the first time in human history, a catastrophe of this magnitude was observed. The attack raised an important question for astronomers. Why is Jupiter unlucky? Space monsters attack it thousands of times more often than the Earth or any other planet in the solar system. All right, let's see. You decide to board a starship and travel to the mysterious Jupiter. A space probe would need 2 years to get there, but your starship is faster. You'll be there in... Great, the journey only took a second. Jupiter is actually big. It could fit 1,300 Earth-sized planets in it. It looks beautiful thanks to gas clouds. This planet has no solid surface, but there's a strange stain on its surface. It looks like a huge eye that can fit 3.5 Earths. This storm will scare anyone. It's 10 times higher than Everest, and the wind rushes at a speed of 300 miles per hour. It's been going on for 350 years. You wouldn't hide from such a storm in a car, so it's good you're in a starship. If all the planets of the solar system merged into one superplanet, the new object would still be 2.5 times smaller than Jupiter. Large size also affects gravity. Spacecraft use Jupiter as a springboard to jump. The giant's gravity increases their flight speed and helps them reach their target faster. Gravity has turned the planet into a magnet for comets, asteroids, and dangerous space debris. Jupiter is a true space superhero. Its gravity shield takes a hit and deflects space monsters that fly into the inner solar system. The dinosaurs don't agree, but more on that a little bit later. What if Jupiter was swallowed up by a giant vacuum cleaner tomorrow? I can only say one thing: we'd have huge problems. Without a giant shield, thousands of comets and asteroids are attacking the planet much more often. Most of them burn up in the atmosphere or aren't large enough to affect us. But there are also larger comets and asteroids. After their collision with the Earth, you can say goodbye to all life on the planet. For example, in 2009, a celestial body crashed into Jupiter. It left a bruise the size of the Pacific Ocean. It's scary to think what traces it would leave on our planet. Most likely, the Earth would turn into a fireball. But recent research from astronomers suggests that Jupiter isn't such a nice guy. On the contrary, it's a bad guy with a slingshot that shoots comets at the Earth. A physicist used computer simulations. He found that Jupiter is equally likely to deflect and send comets toward the Earth. The giant attracts potentially dangerous objects and only partially protects us. It's already tried to knock out our planet many times. 66 million years ago, a cosmic body 10 miles in size crashed into the Earth. The energy of the impact set the surface of the planet on fire. It caused a huge earthquake and tsunami. A fiery rain fell from the sky on the Earth. There were millions of tons of debris and dust in the atmosphere. They stopped the sun's rays from reaching the planet. The nuclear winter began. This disaster led to the extinction of the dinosaurs. Scientists have named this space criminal Chicxulub Impactor. Computer simulations of scientists at Harvard University showed where it came from. Chicxulub wasn't an asteroid, but a comet. This means that the core of its body wasn't stone and metal, but ice, dust, and frozen gas. It resembled a dirty snowball flying through space. The meteorite wasn't going to set fire to the Earth, but Jupiter intervened in the plan. It threw comets in our direction. In 1770, Lexell's comet appeared near the Earth. Our planet and this object were separated by only 1.4 million miles, close to nothing in space terms. Lexell's comet came closer to Earth than any other comet in human history. The object could have stopped life on Earth. The comet flew too close to Jupiter. The giant caught it and sent it in our direction. Now, this isn't a very good move for a superhero that protects the solar system. After 3 years, the comet went past us. It flew 2 times around the Sun and returned to Jupiter like a boomerang. This time, the giant pushed the comet out of the solar system. But let's not blame Jupiter. Scientists believe that without this gas giant, life on Earth would most likely never have happened. Jupiter sent meteorites toward Earth, which carried organic molecules and water with them. They were the building blocks from which earthly life began. Nobody knows if comets would come with a valuable cargo without Jupiter and its dangerous gravity. If you fly away from Earth to the center of the solar system, you'll see the Sun. 8 planets are flying around this star. There's a belt of more than 1 million asteroids between Mars and Jupiter. One theory says there was only the Sun at the very beginning of the solar system's existence. Clouds of stone and dust surrounded the star. These particles attracted each other and formed planets over millions of years. Jupiter didn't want any new neighbors. Its powerful gravity prevented rocks and dust from uniting into planets. They remained asteroids and gathered in a belt inside the solar system. If today all the asteroids merged into one planet, we'd get a cosmic body that would weigh only 4% of the mass of the Moon. Previously, the belt was densely populated, but Jupiter's gravity threw 99% of the asteroids to other places in space. Jupiter isn't the only one that plays a role in the development of life on Earth. Our main assistant is the Moon. It's the only natural satellite of the Earth. Jupiter has 79 satellites, and every year there are more and more of them. Jupiter is also surrounded by rings, but they aren't as beautiful as Saturn's and are practically invisible. The rings are composed of small black particles. This is the dust that the meteorites eject into space after colliding with the moons of Jupiter. The Moon is responsible for the ebb and flow of the ocean. It regulates the life of bees, fish, birds, and amphibians. Even you feel the influence of the Moon every day. Changing the brightness of the disk in the night sky regulates the level of melatonin in your brain. This hormone is responsible for circadian rhythms, which are important for healthy sleep. The Moon came about thanks to another catastrophe, like many other things in space. Millions of years ago, the Earth looked like a ball of hot lava. There was no water or air. It was enveloped only in carbon dioxide and nitrogen. At this time, another planet the size of modern Mars crashed into the Earth. Scientists named it Theia. At a speed of 8,900 miles per hour, it collided with the Earth. The impact of incredible force threw millions of tons of material into space. The debris gathered into a ball that became known as the Moon. Scientists have almost solved the mystery of the Moon, but they don't know if there's a solid core in the middle of Jupiter or if it's dense hot soup that hangs in space. Jupiter has the largest ocean in the solar system. It's made of liquid hydrogen, not water. If Jupiter were 80 times more massive, it would turn into a bright star. Jupiter is a unique place that will never be home to humans. The pressure inside the planet is 2 million times greater than on the surface of the Earth. Extreme pressure and temperature would ruin any spacecraft that's gone too far. I guess that means Jupiter would have a crush on you.
Imagine leaving your house one morning and seeing not one, but 2 stars shining in the sky. The first one is our good old sun, and the other is Jupiter. But how has a planet turned into a star? And what will now happen to Earth and its inhabitants? Before we find the answer to these urgent questions, we need to revise some things we know about Jupiter. The largest planet in the solar system is a gas giant, which means it's made up mostly of gases. Due to the pressure and temperature differences, these gases separate into layers. This creates those red and white bands that can be clearly seen from Earth. The temperatures at the top of Jupiter's atmosphere are insane. They can reach a whopping 1,340 degrees Fahrenheit. The planet also has an immense gravitational pull. In 1995, the Galileo probe reached the atmosphere of Jupiter and sliced it at a speed of 106,000 miles per hour. It survived the scorching temperatures and started its descent. It kept moving even when the temperatures suddenly dropped and the pressure, as well as the speed of the wind, increased. But 58 minutes and 97 miles into its exploration, things went downhill. The pressure of 23 atmospheres and still high temperatures finished the probe off. It was melted and then vaporized by the extreme heat. Now, if Jupiter suddenly decided to keep growing, it would eventually become a star. And its composition would allow this planet to do it. Once, a long time ago, Jupiter took most of the mass that was left after the formation of our Sun. That's how it ended up with more than twice the combined material of all other bodies in the solar system. And the planet's ingredients are the same as those of a star, mostly hydrogen and helium. Jupiter is just not massive enough to ignite. But what if it was? Then it would turn into another kind of celestial body, most likely a brown dwarf. In this case, it would have a minor effect on the orbits of the planets of our solar system, because brown dwarfs are more massive than planets, but not as massive as stars. A brown dwarf is usually 13 to 80 times the mass of Jupiter. It can only become a star if the pressure in its core gets high enough to start nuclear fusion. So let's imagine that it's happened, and Jupiter has become a real star. For example, a red dwarf. Red dwarfs are stars with masses around 7.5% to 50% of the mass of our Sun. Red dwarfs are also hotter than brown dwarfs. Their temperature can reach 6,380 degrees Fahrenheit. Our Sun, by comparison, has a temperature of almost 10,000 degrees Fahrenheit. So, it means that the newly formed red dwarf will be far dimmer than the Sun. And still, red dwarf Jupiter could prevent the inner planets from following their orbits, because they wouldn't be able to find a balance between the gravitational forces of the two stars. The planets would move either closer to the Sun or closer to the newly formed red dwarf. If Earth chose the first option, our main star's insane temperatures would probably wipe all living beings off the face of the Earth in no time. If it was the second scenario, we'd probably freeze, since Jupiter, as a dim red dwarf, wouldn't be able to warm us up well enough. But there could be one more option. The inner planets could get thrown out of the solar system altogether. If Jupiter was a star, it would also greatly increase the amount of radiation the surface of Earth would receive. Our atmosphere would have to protect us both from the radiation coming from the Sun and from Jupiter's radiation. Red dwarfs are notoriously active. That's why Jupiter, just like the Sun, would most likely have frequent coronal mass ejections. This is a fancy expression for describing large clouds of electrically charged particles a star releases with a huge burst of speed. Even now, Jupiter has a significant impact on our planet. The gas giant is roughly 318 times as massive as Earth. And this also means it has an outsized pull on our planet. Its gravity can cause shifts in the orbit of our planet and climate swings every 400,000 years or so. When Jupiter's influence is the strongest, Earth usually has colder winters, hotter summers, and more intense periods of wetness and droughts. Also, if Jupiter turned into a red dwarf, its most prominent feature might probably disappear for good. I'm talking about the Great Red Spot. It's an enormous storm raging in the southern hemisphere of the gas giant. Its top parts tower more than 5 miles above the tops of the surrounding clouds. The storm is almost twice as wide as our planet. In 2017, NASA's Juno space probe managed to collect lots of data about the red spot, and it turned out that this monster of a storm went more than 200 miles down into the planet's atmosphere. That's 30 to 100 times deeper than any ocean on Earth. But these measurements are most likely imprecise, and the storm's true roots can be reaching even deeper. The Great Red Spot is colder than the rest of the atmosphere, and keep in mind that Jupiter's temperatures are negative 280 degrees Fahrenheit in the upper cloud layers. On the other hand, the closer to the core, the hotter it gets. Mysteriously, the highest temperatures ever recorded on the gas giant occurred in the atmosphere right above the Great Red Spot. They were higher than the temperature of lava on our planet. Astronomers believe that the turbulence caused by the storm might produce gravitational and sound waves that can be responsible for the superheating. But the storm itself is warmer at the bottom than at the top. People have been watching the moving vortex on Jupiter for more than 150 years. Some time ago, astronomers predicted that it would gradually slow down and become smaller or disappear altogether. But that turned out not to be the case. After having analyzed all the data received with the help of the Hubble Space Telescope, researchers were baffled to discover that the winds at the outer boundaries of the storm had actually picked up speed. The wind speed at the edges of the storm can reach a mind-boggling 400 miles per hour. That's faster than Earth's tornadoes. At the same time, if you found yourself at the center of the Great Red Spot, you wouldn't be too impressed. The winds there move way more slowly. And now, I have another what-if situation for you. What if Jupiter collided with the smallest star we know about? Today, these two space bodies are on a collision course. A spoiler, Earth might not survive such an encounter. Okay, meet this tiny red dwarf. It's the size of Saturn, and its gravity is around 300 times the gravity of our planet. It normally floats 600 light-years away from Earth in a double star system. But today, for some inexplicable reason, it's broken all the laws of the universe and is rushing toward the biggest gas giant in our solar system. And even though this space guest is smaller than Jupiter, its mass is way greater, and its gravitational force soon starts to pull on the gas giant. The heat from the red dwarf, plus its powerful gravity, makes Jupiter grow in size. The planet's atmosphere starts to puff up because the gases that make up the planet begin to heat up and expand. Jupiter's atmosphere starts to leak into space toward the stellar visitor. Sometime later, the runaway gases form a bright hot ring around the red dwarf. This is a terrifying view, as if a black hole, a very bright one, has appeared inside the solar system. The star keeps tearing Jupiter apart, eating chunks of the gas giant, and soon the red dwarf engulfs it completely. Sadly, Jupiter never stood a chance. Instead of the gas giant, we now have a red dwarf surrounded by a ring of hot gases. And we already know how badly it may end. The best thing about it is that this scenario is totally imaginary. Phew, thank goodness. Sand is everywhere. In your eyes and mouth, in your hair, under your t-shirt, and in your shoes. You can hardly stand. The wind is so strong, it's knocking you down. Suddenly, an especially powerful gust sends you to the ground. You crawl toward the back door. It takes you a lot of effort just to pry it open. Once inside, you get to your feet and sneak a peek outside. Just clouds of dust and a deafening roar. Okay, it's time to call for help. It started a month ago. One day, you went out to the garden behind your house. It was a windy day. You even spotted a tiny tornado under your apple tree. It hardly reached your knee, lazily swirling around tree leaves and dust. You tried to make it disappear by poking it with your foot. But even after several attempts, the mini whirlwind just didn't want to break apart. You shrugged and went back home. The next day, the tornado was still there, and had it grown? Interestingly, instead of growing taller, it got wider. At that moment, it started munching on your flowering shrubs. You got curious and decided to keep track of this unusual phenomenon. You measured it every day and carefully wrote down all the information in a special notebook. Maybe later I'll write an article or even publish a book about my storm, you thought. One day, you got out of the house to find your favorite apple tree broken. You couldn't figure out how it happened. The storm still looked harmless and too weak to damage a rather large tree. But after this accident, you started asking yourself if not calling for help was the wrong thing to do. Apparently, it was, because just a month later, your mini storm has suddenly grown to twice its original size. It's unsafe to go outside now. It seems as if your house is in the middle of a real tornado. You can't see the sky behind a wall of dust and debris. Your garden is ruined, trees broken, bushes and shrubs pulled out of the ground and sent flying somewhere far away. You hear your doorbell ring. A group of scientists you invited has come to the rescue. You show them the garden with your personal natural disaster and enjoy their stunned silence. But after a couple of seconds of initial shock, they spring into action. Ignoring the howling wind, they start carrying inside different equipment. It looks very complicated. Your kitchen turns into the researchers' laboratory. You get informed that your house will be temporarily used by the scientists. You take your things to the smallest bedroom and watch the professionals work. Your kitchen is filled with beeping gadgets and devices covered in flickering lights. People in protective suits and lab coats scurry around. Surprisingly, they don't bump into each other. Neither do they create traffic jams. You bring the notes you've been taking and hand them to an elderly man in a white lab coat. He thanks you as if you've just given him the gift of his dreams. The next several days pass in a flurry of activity. The storm in your garden is growing. The scientists seem to get gloomier every time you see them. It's around 2 a.m. when something wakes you up. You blink your eyes open and realize the house is shaking. Your homegrown tornado must have gotten so big, it's reached the house. In the morning, several scientists pull you aside to tell you the unpleasant news. You have to move out. The storm is indeed growing. Soon, it'll wipe your house off the face of the earth. Nothing can be done. You're gaping at the people telling you to get out of your house. Where will you go? They tell you they're building an additional research lab not far from the place. It's important to be able to observe the storm in real time. Anyway, there's a spare room with everything you may need in that facility. Why don't you stay there for a while? It would also be convenient for the scientists. They may need you to answer the questions that appear during the process. You agree because you don't have any other choice. The researchers help you transport your stuff to your new accommodation. You walk around your house, saying goodbye to your favorite coffee table, your sofa, and your cozy bed. The scientists tell you that there's no time to move your furniture to another place. The next day, you wake up to the news that your home is gone. The storm gulped it down at around 4 a.m. Over the next few weeks, the grown-up whirlwind has swallowed 2 houses of your neighbors, the nearby forest, several abandoned cars, and a small flower store. It's now so big, it's coming close to a large lake several miles away from the town. People get evacuated. The authorities have announced a state of emergency. One day, you notice that scientists are talking in hushed voices. They look even more worried than usual. You corner one of them and try to find out the truth. Soon the scientist spills it. The researchers have got some evidence that confirms their worst fears. According to all their estimates, the storm that once started as a tiny tornado in your garden is going to grow into another great red spot. Only on Earth. Crimson-colored clouds are spinning counterclockwise at an incredible speed. Beneath them, you can see vibrant hues of the largest planet in the solar system, the gas giant Jupiter. Those clouds are called the Great Red Spot. It's a colossal storm raging in the atmosphere of Jupiter. If you found yourself at the storm's center, the winds would be rather calm there. But on the edges, the storm's speed can reach 425 miles per hour. That's twice the speed of the fastest and most severe hurricanes on Earth. Over the decades, the size of the red spot has been changing. Right now, it's 1.3 times as wide as our planet. The storm's roots go as deep as 200 miles into the planet's atmosphere. The average tropical cyclone on Earth usually stretches for no more than 9 miles from the bottom of the storm to its top. The unique phenomenon on Jupiter has existed for so long because the planet doesn't have a solid surface. It consists of layers of clouds made up of vapor, water ice, and ammonia. Underneath, there might be an ocean of liquid hydrogen. Our planet is solid, and hurricanes slow down and break apart once they go low enough to touch the surface. But the Great Red Spot has nowhere to make landfall. That's why it keeps raging. The scientist also tells you the most bizarre and alarming thing about the storm in your garden. Instead of growing weak and disappearing many weeks ago, it's not only still going, but it's also getting bigger and more powerful. Even the most experienced specialists can't explain this phenomenon. After analyzing it for days on end, they've come to the conclusion that it shouldn't have appeared on Earth. It's against the laws of nature. Interestingly, the storm's composition is a bit similar to that of the Great Red Spot. You're impressed, but still can't get why the researchers look so worried. It turns out that your once mini-storm is likely to grow as large as that on Jupiter. But since Earth is way smaller than the colossal red spot, it's likely to swallow our planet whole. It'll grow and grow, wiping out towns and cities, forests and highways. At the same time, it'll become more powerful. People will have to leave their homes and get evacuated to relatively safe areas, until there are no more safe areas left. This process will take years, but it'll still be too fast for people to prepare. There will be 2 ways to deal with this global problem. One of them is to colonize the moon or another planet, for example, Mars. But it's an incredibly long process, and the storm will conquer the entire planet before the first spacecraft with people leaves Earth. Or scientists may try to stop the hurricane. There's a technology called the sunglasses effect. Billions of tons of dense gas get pumped into the atmosphere. This gas absorbs sunlight and cools down ocean water, which is the engine of any hurricane. The researchers aren't sure if this method will work with your storm. It formed not over the ocean, but in your garden. Black holes, an enigma that has puzzled scientists and captivated our imagination for decades. But what's hiding inside of a black hole? Is it a void? A bottomless pit? A parallel universe? We don't know for sure yet, but scientists might have some ideas. So let's hear them out. Picture this. In the vastness of space, there's a supermassive star, shining bright like a diamond. But like all good things, this star's party can't last forever. Eventually, it runs out of fuel and goes out with a bang. Quite literally, the star collapses under its own gravity, creating an implosion. Now, this collapse is so intense that it creates a bottomless pit in space, like a sinkhole. This is what we call a black hole, the ultimate no-escape zone, sucking up everything in its vicinity, including light. Imagine yourself approaching a black hole. The black hole itself doesn't emit any light, but you can notice a dazzling display of cosmic fireworks surrounding it, the accretion disk. It's like a celestial carousel of gas and dust swirling in a mesmerizing dance around the black hole. The incredible gravitational forces pull all this material from their surroundings, creating this celestial furnace. Of course, it's very unlikely that you would have survived in this place. Temperatures here soar to millions of degrees. Also, it's constantly dazzling X-rays and high-energy radiation that can be detected from telescopes on Earth. But let's imagine that you did survive, somehow. As you get closer, you notice a mysterious boundary looming ahead, the event horizon. It's a point of no return, beyond which the laws of physics seem to go haywire. Now you're stuck in a space traffic jam, and no matter how hard you hit the gas, you're going nowhere. Once you cross this threshold, not even light can escape. And now, you inevitably fall into a black hole. What do you see around you? According to the genius physicist Albert Einstein, space and time aren't separate entities, but rather intertwined in a fabric called space-time. It's like a cosmic trampoline that can stretch and bend if you place something heavy on it. And black holes are super heavy, which is why they distort this trampoline in the most extreme way possible. So, when you venture close to a black hole, you're in for a roller coaster ride. The curvature of space-time becomes so intense that it's like a whirlpool pulling everything in, even light itself. Everything around you looks like a space funhouse with distorted colors and rays of light that keep shifting. All this makes you feel like you're doing the moonwalk on a treadmill. Also, the curvature of space-time around a black hole is so extreme that it creates a phenomenon called time dilation. Time near a black hole moves at a different pace than in the rest of the universe. The closer you are to the black hole, the slower time ticks, like a slow motion effect. And the deeper you fall, the weirder things get. The laws of physics seem to break down before your very eyes. But suppose you somehow manage to survive all this madness. Where exactly are you falling? What awaits you on the other side? Is there even an other side? As you venture deeper into the celestial maelstrom, you reach an elusive and mysterious point called the singularity. It's the heart of a black hole, a place where all matter and energy are crushed into a single, unimaginably dense point. Imagine cramming masses of entire stars to something that is essentially a pinprick. And now that you're here, forget about the usual rules of physics. Welcome to a new realm, where the known breaks down and the unknown takes over. So, what does this unknown look like? Well, there are a couple of theories. First off, it could be a gateway to other dimensions. What if there are multiple universes hiding within black holes, like nesting dolls? According to this theory, the interior of a black hole could be a portal to a parallel universe with its own set of physical laws and possibilities. This parallel universe could be drastically different from our own world. What a mind-bending idea! Or what about wormholes? Imagine black holes forming a space subway system, connecting different regions of space and time with each other. These theories suggest that the extreme gravitational pull of a black hole could create a wormhole, a tunnel that could transport you to another galaxy, or even to the past or future. It's like finding a secret passage in a video game. That's not all. Some scientists propose that inside a black hole, we might find some exotic matter, some strange matter with weird properties or negative energy density. If that's the case, this would defy our understanding of the universe. And finally, one of the most mind-bending theories is that a black hole could actually lead to a white hole. Imagine, as you fall further, you suddenly find yourself in a blindingly bright space show. You're in a white hole. This is a fountain that's spewing out matter, energy, and information into the universe with reckless abandon, the birthplace of new universes. You see, while black holes are known for their event horizon, white holes have an anti-event horizon. With black holes, everything can enter and nothing can come out. With white holes, it's the other way around. They repel everything. White holes are hypothetical objects. Their existence hasn't yet been proven. But if it turns out that they exist, they could be connected to black holes. It makes sense. Black holes suck everything in, and white holes should take their matter from somewhere. And all this matter and energy coming out of the white hole could potentially form new universes. Together with black holes, they could form a universal cycle of creation. The end of one universe leads to the birth of another. All these theories are beautiful and fascinating, but here's the catch. There's still no concrete evidence of any of them. Black holes still remain one of the biggest mysteries of our world. Unfortunately, studying these mysterious beasts isn't easy. They're super elusive, and this is one of the biggest challenges for scientists. Black holes don't emit light, so they can't be seen directly. They're essentially invisible to telescopes that rely on light, making them incredibly difficult to observe. That's why scientists have to rely on things like X-ray emissions, the effects of a black hole's gravity on nearby objects, and other clues. They're also very unpredictable. For black holes, physics is like a fun playground. They warp space and time around them, which makes it difficult to predict and understand their behavior. But don't worry, space enthusiasts. The future of research in this field is as promising as ever. We've already made incredible discoveries. For example, in 2019, we captured the first ever direct image of a black hole. This is a central black hole of the galaxy Messier 87. A few years later, we also took a photo of a black hole in the center of our own galaxy, the Milky Way. This one is called Sagittarius A star. All this has opened up new avenues for research. And these aren't the only cool things we've discovered in recent years. Let's take gravitational waves, for example. You know how rocks leave ripples after falling into water? Well, gravitational waves are ripples in the fabric of space-time. They carry clues about the most cataclysmic events in the universe. They've allowed us to listen to the universe, unveiling previously hidden phenomena and events. And all these observations provide us with a new way to study black holes. We constantly make new advancements in technology. The James Webb Space Telescope will provide us with even more detailed observations and insights into the mysteries of black holes. There's still so much we don't know, but that's the beauty of science, the thrill of the unknown, and the curiosity that drives us to explore the mysteries of the universe. So, let's keep peering into the cosmic abyss on the thrilling quest to unlock the secrets of our world. Jupiter has 79 known moons, and the 4 biggest of them that are particularly interesting are Galilean moons. They were named after Galileo Galilei. He discovered them in the 17th century. They have something in common, but at the same time are all very different. Europa is the smallest of the Galilean moons with a diameter of 1,860 miles. It orbits Jupiter every 3.5 days. The first images we got from there were taken in the 1970s. Its surface mostly consists of water ice. Europa has long fractures, often around a mile wide, that can extend for thousands of miles across its surface. They were probably formed as the crust pulled apart from tidal forces on the mysterious ocean beneath the surface. In 2012, scientists discovered water vapor plumes erupting close to its south pole, rising up to 125 miles. These plumes can help us find what's inside Europa without having to land there. Scientists think there could be a magnificent ocean hidden 10 to 15 miles beneath the solid surface. That ocean could be 40 to 100 miles deep. Even though it's just 1/4 of Earth's diameter, it contains twice as much water as all of our oceans together. This ocean is a potential environment for some forms of life. Scientists believe the entire ice crust is floating on that ocean. It probably makes a full rotation around Europa once every 12,000 years. In the image the Galileo spacecraft took, you can see small dark brown spots. They're 6 miles across and formed as the hot, less dense material was getting to the surface. It either pushed the crust or broke through it altogether. The surface of Europa consists of so-called chaos terrains. They're rough areas surrounded by a smoother surface. Its equator could be covered in ice spikes called penitentes that can go up to 50 feet high. We have them on Earth too, especially in dry areas at high altitudes. But none of them are as big as those on Europa. Our moon has over 5,000 big craters with a diameter of more than 15 miles. Europa's surface lacks impact craters and doesn't look like it's more than 50 million years old. This means the surface of Europa is changing and reforming all the time. This moon is icy and is one of the smoothest of any solid space objects in our solar system. Because of it, it's 5 times brighter than our moon. Europa is under a constant blast of radiation coming from Jupiter. It's so strong, we wouldn't last even a day there. Europa is 5 times further away from the center of our solar system than Earth. That means it barely gets any heat coming from the sun, so it can remain frozen since the average temperature is negative 250 degrees Fahrenheit at the equator and around negative 360 degrees Fahrenheit at the poles. About 40 years ago, the Voyager 1 spacecraft came close to the rocky moon Io and discovered that it's a volcanic champion of our solar system. Io is Jupiter's 5th innermost moon, 4.5 billion years old, nearly the same age as Jupiter itself. It's similar in size to our moon, and even has a similar density and amount of gravity. Many moons in our solar system consist of silicates and water ice, but Io is made of iron and silicate rock. You'd be able to see some beautiful auroras on Io. As this moon rotates around Jupiter, auroras change brightness all the time, but they're always there. Io is relatively close to Jupiter, almost 260,000 miles above its cloud tops. If you could come to Io and take a look at Jupiter from there, it would appear almost 40 times bigger in the sky than our moon. Stargazing there would be amazing. Io needs 42.5 hours to orbit Jupiter. Our moon needs almost a month. At some points, Io's tidal bulge can go up to 330 feet. It's similar to what we have on Earth. The gravity of our moon causes ocean tides. Io doesn't have an ocean, but the ground itself moves and goes up and down. It's like an elevator taking you to the bottom and then the top of a building with 30 stories. The gravity of Jupiter and its other big moons affect Io, so the solid ground tides on its surface are over 5 times as high as the highest ocean tides on our planet. All this makes Io so hot on the inside that some of the inner materials melt, boil, and try to escape in any way possible. Eventually, it creates a hole in the ground, which then turns into a volcano. Io is the most active body in our solar system when it comes to volcanoes. Io has more than 400 of those, with 150 of them erupting all the time. Some of them shoot their hot gas plumes 200 miles into space. It would be difficult to walk there because we're talking about a pretty intense world of floodplains of liquid rock, huge lava flows, multiple lava lakes, and giant collapsing mountains. Ganymede, the largest moon in the solar system we know of, also has the biggest water ocean. It's 26% greater than Mercury when it comes to volume, but it's less dense. This giant moon has a thick crust of water ice 90 miles deep. There might be a huge ocean of liquid water underneath. It extends 60 miles deep, which is about 10 times deeper than the deepest point in the Earth's ocean. The Voyager spacecraft also detected polar caps made of water frost there. Ganymede is half rock, half water, including tiny amounts of metals and ice. Its atmosphere is very thin and doesn't contain oxygen. This ocean most likely doesn't contain life. The Earth is a great example of how certain microbes and creatures can survive deep down without sunlight. But the ocean of Ganymede is so deep and the pressure is so strong that the water at the bottom is probably compressed back into ice. Certain forms of life in the deepest areas of our ocean survive thanks to geothermal vents that eject minerals. Since there's likely thick ice between the ocean and the core, this isn't the case with Ganymede. But the ocean there is salty, with multiple layers divided by icy sheets. If there's any chance of life, it could be in the part where the rocky core is in contact with the most internal icy layer. Beneath all that water and ice, Ganymede is the only moon in the entire solar system with a magnetic field. It's possible because this moon has a liquid core. Ganymede circles Jupiter approximately once every 7 days. Its orbit is so eccentric that at some points, it's pretty close to Jupiter. Ganymede, Io, and Europa have gravitational forces that affect each other. In the time Ganymede orbits Jupiter once, Europa makes 2 orbits, and Io makes a full circle 4 times. 1/3 of Ganymede's surface contains big dark regions, while the other 2/3 are lighter. Dark areas are older and contain more craters. Lighter areas have long ridges and grooves, about 2,300 feet high and thousands of miles long. Callisto, the 3rd biggest moon in the solar system, 3,000 miles in diameter, needs 17 Earth days to orbit Jupiter. Its atmosphere is very thin. There are many impact craters, but its ancient crust has basically been the same for more than 4 billion years. When a planet is geologically active, like the Earth, some things can erase most of the evidence from past impacts. Water, volcanoes, tectonic plate movements, human activity, and weather. All this changes the surface. Callisto has experienced none of those. Scientists think this moon used to be an ocean world that eventually froze over. It was hit by meteors from time to time, but mainly remained untouched. And yet, it still has some pretty impressive craters, like Valhalla, the biggest multi-ring crater in our solar system. That's 2,500 miles in diameter. Major craters on Callisto contain more rings than those on other celestial bodies. Whatever hit the moon was big enough to have punctured the thin crust, causing water to spread on the surface. And under this thin crust, there could be either salty ocean or soft ice. The Galileo space probe detected that Jupiter's magnetic field couldn't penetrate through this moon, likely because of a layer at least 6 miles thick. That's why it's hard to explore Callisto. Moons like Europa have vents that eject water from the subsurface oceans. But to explore Callisto and discover more about its past, we'd have to use the old-school way, digging through the crust. If we wanted to explore the outer parts of our solar system, Callisto would be a great spot because Jupiter's radiation doesn't reach it. So we'd be safer there than on some other inner moons.
Look up. The sky is dark, seemingly lifeless. But then, you notice something that wasn't there before. A bizarre, almost invisible light illuminates the previously black space. It's too late to run. You're both lucky and unlucky at the same time. You're witnessing the awakening of a giant, previously dormant black hole. Is it going to swallow both you and our world? Supermassive black holes, huge space objects millions of times heavier than our Sun, live in the middle of most galaxies. But they're really hard to see or study. Most of the time, they sit quietly and don't do much for a long time. That's what was happening with a giant black hole in a faraway galaxy. This galaxy is 300 million light-years away from us, in a part of the sky called Virgo. For many years, the black hole there wasn't doing anything exciting. It was quiet and resting. But in late 2019, something strange happened. The galaxy suddenly got much brighter. It started flashing a powerful X-ray light. It was something scientists hadn't seen there before. This surprised astronomers, so they started watching it closely. After a few years of studying it, scientists have concluded that the black hole has likely woken up from its quiet state and become active. Now, the middle of the galaxy is really bright. It might mean the black hole is pulling in material and producing lots of energy. Astronomers even gave this black hole a fun nickname, Ansky. And the coolest thing about all this is that it's the first time we're watching a supermassive black hole switching to an active state in real time. Scientists at the European Southern Observatory in Germany were the first to notice something strange. They used special space telescopes, like NASA's Swift and another one called eROSITA, to look for X-rays coming from Ansky. At first, they didn't see any. Then, in February 2024, another group of scientists noticed something new: bursts of X-ray light coming from Ansky. And these bursts weren't random. They happened almost like clockwork, at nearly regular times. This kind of flashing has a complicated name, quasi-periodic eruption, or QPE if you want to make it short. It's when a black hole suddenly flares up with a burst of energy, but only for a short time. And this is the first time anyone has seen a QPE in a black hole that was waking up after being quiet for so long. These kinds of events are also super rare. Scientists only found the first QPE in 2019, and they've only seen a few more since then. No one knows exactly why they happen, but watching Ansky might help scientists learn more about how black holes behave and grow. One important tool they used was the XMM Newton Space Telescope. It's the only one that can see the very faint background light between the flashes. By measuring how dim Ansky gets between bursts, scientists could figure out how much energy the black hole sends out during each flare. You might know that black holes have super strong gravity that pulls in anything that gets too close, even stars. If a star gets caught, it can be stretched and torn apart. The pieces of the star form a super-hot glowing ring that spins around the black hole. This ring is called an accretion disk. Scientists think that the quick flashes of X-rays, QPEs, might happen when something, like a star or even another small black hole, interacts with this spinning disk. QPEs have sometimes been linked to stars being destroyed. But with Ansky, there's no sign that it destroyed a star. So scientists started thinking of other reasons. Maybe the disk around Ansky is made from gas that the black hole grabbed from nearby space, not from a torn-up star. And maybe something small, like a planet or a star, is passing through this disk over and over again, shaking it up and making it flare with bright X-ray light each time. What makes Ansky really special is how big and powerful its bursts are. According to a student at MIT who worked on the study, Ansky's X-ray bursts last 10 times longer and are 10 times brighter than normal QPEs. Each burst gives off 100 times more energy than other ones scientists have seen. And the timing is strange too. Ansky has a pattern of flashing about every 4.5 days. It's the longest wait time between flashes ever seen. These strange features are making scientists rethink how QPEs happen and what causes them. Sadly, we don't have enough data yet to know for sure. Astronomers need to watch more of these events to figure it out. Now, you might be wondering how scientists even find black holes. After all, they capture everything, even light. Indeed, these space monsters are really hard to see. They're basically invisible. But scientists pay attention to what's happening around them. It can be glowing gas and dust somewhere in space. The thing is, black holes often have a spinning ring of gas and dust around them, called an accretion disk. This ring gets super hot and shines in X-rays and other kinds of light, which telescopes can spot. It can also be moving stars. Big black holes, like the one in the middle of our Milky Way galaxy, have such strong gravity that they make stars orbit around them. Scientists watch these stars move in special patterns and prove that there's a giant black hole hiding there. This discovery won a Nobel Prize in 2020. They're also on the lookout for ripples in space. because when giant objects like black holes move or crash into each other, they send out gravitational waves. Scientists have built special tools to feel these ripples and learn more about black holes. And finally, it's bending light. Black holes have so much gravity they can bend light from stars behind them, like a cosmic magnifying glass. This trick, called gravitational lensing, can help scientists find black holes that are hiding all by themselves. Now, you should keep in mind that, unlike some stereotypes, black holes are not wormholes, magic tunnels that take you to other places in space or different universes. Once you get into one, there's no way out or to the other side. Neither are black holes some kind of space vacuum cleaners. They don't go around swallowing everything they come close to. If you're far away, their gravity is just like that of any other object with the same mass. The black hole that's closest to us on Earth is called Gaia BH1. It's about 1,500 light-years away. As for the farthest black hole we know about, it's located in the middle of a faraway galaxy 13 billion light-years away. The largest black hole we've seen is called TON 618. It's 66 billion times heavier than the Sun. And the smallest black hole is just 3.8 times heavier than the Sun and sits next to a star. By the way, all black holes spin or turn really fast. The fastest one spins over 1,000 times every second. Plus, big black holes in the middle of galaxies can shoot out particles at super high speeds, almost as fast as light. If something falls into a black hole, spaghettification occurs. This object gets stretched out in space like a noodle because of the black hole's immensely strong gravity. And speaking of gravity, if our Sun were replaced with a black hole that had the same mass, Earth and the other planets would still orbit it in the same way. The gravity wouldn't change just because it's a black hole. Scientists have discovered two main kinds of black holes. The first are called stellar mass black holes, and they're usually about 5 to maybe 50 times heavier than our Sun. The second type is supermassive black holes, which are incredibly huge. Some of them 100,000 times to even billions of times heavier than the Sun. There might also be middle-sized black holes, kind of like the in-between type, but no one has found one for sure yet. Stellar mass black holes can form when two neutron stars smash into each other. Also, two smaller black holes can join together and make a bigger one. That's one way black holes grow. But supermassive black holes are still a big mystery. Scientists aren't exactly sure how the universe creates black holes that large.
Buckle up, fellow space enthusiasts, because we're about to uncover the celestial secrets that have been unveiled this year. From giant stars to organic molecules, this year is going great for astronomers. So let's catch up on all the excitement you might have missed in 2023. First of all, we've discovered some real astral monsters. Imagine looking up at the night sky and seeing stars that are not just big, but absolutely enormous. Scientists have been using a special telescope called the James Webb Space Telescope to explore the early days of the universe. And during their adventure, scientists stumbled upon ancient stars that are 10,000 times bigger than our Sun. Yes, you heard it right, 10,000 times. These giants of the stellar world were some of the very first stars ever to form in the universe, billions of years ago. Imagine a globular cluster as a massive cosmic crew, where each group consists of a whopping 100,000 to 1 million members. These clusters are like giant family gatherings, with all the stars being born around the same time. But what makes these newly discovered monsters so special? Well, their cores, or their central parts, are way hotter than what we see in stars today. Scientists think that this intense heat might be due to a lot of hydrogen burning at really high temperatures. It's like they're having a galactic barbecue party. Something fascinating happens in these globular clusters. The smaller stars crash into the supermassive ones and gain extra energy, like a power-up. But here's the twist. Most of these clusters are now getting old, and the supermassive stars disappeared a long time ago. We can only see hints of their existence in the clusters we observe today. Scientists study them by just the mysterious traces of their grand presence. The discovery of these monster stars is incredibly important for our understanding of the universe. If scientists can gather more evidence to confirm their existence, it would be a major breakthrough. It would help us learn more about globular clusters and how supermassive stars form in general. But that was only the first fascinating discovery of 2023. Although the next one is kinda sad. You know those beautiful rings that make Saturn look so fancy? Well, guess what? They might disappear in the not-so-distant future, astronomically speaking. NASA's Cassini mission, which explored Saturn from 2004 to 2017, gathered some fascinating data about the rings. During Cassini's grand finale, when it did some cool maneuvers between Saturn, scientists noticed something surprising. The rings were losing a lot of mass every second. Tons of it. That means this magnificent halo will only stick around for a few 100 million more years, at most. That may seem like a long time for humans, but in the grand scheme of the universe, it's just a blink of an eye. The important thing is that we've learned that huge rings like Saturn's don't last forever. They eventually fade away. Oh, well, at least you and I personally won't catch this moment. Scientists have a fun theory about what will happen when Saturn's rings disappear. They think that the other ice and gas giants in our solar system, like Uranus and Jupiter, might have once had massive rings too. But over time, those rings wore down and became more like the thin, wispy bands of asteroids like what Uranus has now. Saturn's rings are mostly made of ice, but they also have a sprinkling of rocky dust. This dust comes from asteroids and teeny tiny meteoroids crashing into the celestial objects and breaking apart. It's like a snowstorm of icy particles and space debris. The research also revealed that Saturn's rings appeared long after the planet itself formed. They were still forming when dinosaurs roamed the Earth. So, in terms of astronomical age, they're actually quite young, only a few 100 million years old. This discovery has got scientists all excited because it means something dramatic happened in Saturn's past to create this stunning icy disk. But this is a mystery waiting to be solved. Scientists want to figure out what exactly caused the rings to form and why they have such a breathtaking structure. Let's hope they'll figure it out. But moving on to something more optimistic, we have another exciting space news. Recently, scientists have been studying one of the most distant galaxies in the universe, and they found something amazing: organic molecules. The galaxy in question has a long name, SPT-041847. It's over 12 billion light-years away from our little blue planet. Can you even imagine that distance? It's the farthest galaxy ever known, where complex organic molecules have been found. That's why looking at this galaxy is like looking at something from when the universe was just a baby. We have no idea what this galaxy looks like now. The light that has reached us is what it looked like when the universe was only 1.5 billion years old. Imagine being able to see things from so far in the past. So what they found is something with a very complicated name: a polycyclic aromatic hydrocarbon molecule, or simply PAH molecule. You might be wondering, what in the world is that? Well, guess what? You can actually find these molecules right here on our planet. They can be in things like the smoke from car engines or even forest fires. PAH molecules are made up of chains of carbon atoms. And here's the super cool part: they're considered the basic building blocks for life. Imagine that, life's building blocks. Those tiny carbon chains being discovered in a galaxy that's so far away. That's like finding a needle in a haystack. They also found out that gas floating around in that galaxy is filled with heavy elements. That's a big deal because it suggests that many stars have come and gone there, creating all these amazing elements. This means that this galaxy can be potentially rich in many other elements too. This discovery opens up a world of possibilities and raises so many exciting questions. How did these molecules form in a galaxy so distant? And since we're looking into the past, what could have happened to these organic molecules during this time? Could they have evolved into life? We're only scratching the surface of the incredible things waiting to be uncovered. By the way, if it's so far, how did scientists even manage to discover something like that? Well, they had the instrument called the James Webb Space Telescope. This fancy telescope was recently launched and has superpowers when it comes to observing the universe. So when the scientists were studying this faraway galaxy, they had a little problem. The light coming from those distant objects was so faint that it was hard to see or detect. But guess what? They had a brilliant idea to solve this. They used something called gravitational lensing, which is like a special power of nature's magnifying glass. Imagine two galaxies lining up perfectly, just like in a photo shoot. The light from the faraway galaxy, the background one, travels towards us. But on its journey, it passes through the foreground galaxy, which is like a giant space lens. And guess what? The foreground galaxy's gravity bends the light, just like a magnifying glass, making it bigger and brighter. It's like having a cosmic zoom lens for our telescopes. This bending of light creates a super cool shape called an Einstein ring. It's like a halo, or a ring of light surrounding the foreground galaxy, basically a nature's way of showing off its magical powers. With gravitational lensing and these beautiful Einstein rings, scientists can see distant objects more clearly and learn amazing things about the universe. And thanks to all that, they managed to uncover the hidden chemical interactions from the early galaxies. Isn't that incredible? The scientists are beyond excited about this discovery. They never expected to find such complex organic molecules in a galaxy that's incredibly distant. Who knows? Maybe this is just the beginning of a thrilling cosmic journey. So, keep your eyes on the stars, fellow space explorers. The universe is full of surprises, and who knows what other mind-blowing discoveries await us out there. Let's hope we'll learn even more in the future.
This catapult-like system on the moon might bring us limitless energy. It's a launch system concept that was recently proposed by the Chinese scientists. It would work like a hammer throw, spinning a launch arm that flings objects. This arm is supposed to be about 165 feet long. It will accelerate until it reaches the moon's escape velocity, and then whoosh, the capsule is sent into space. This crazy idea will cost around $18 billion. Ooh, pricey. But trust me, it's totally going to be worth it. The system would be powered by solar panels and nuclear energy. It could also recover more than 70% of the energy used after each launch. The moon has a very weak gravity. There's also barely any atmosphere, so the air doesn't weigh you down. This makes it so much easier to launch stuff there. But why do we even need this? The main purpose is to transport helium-3. It's a really cool isotope of helium, and one of the most insane things about it is that it could become fuel for nuclear fission. This is the same process that happens in stars, including our Sun. If we manage to recreate nuclear fusion here, on Earth, we can make it a clean and basically limitless source of energy for power plants. But helium-3 is super rare on Earth. We can sometimes find it in volcanic rock formations on the ocean floor. That's because it's a product of another rare element called tritium, the element we usually make in nuclear reactors and put in cool stuff like glow-in-the-dark paint. But the catch of tritium is that it takes forever to decay and turn into helium-3. Now, there's a bunch of helium-3 on the moon, around 1 million tons. Just 20 tons of helium-3 could meet China's yearly electricity needs. In fact, lunar soil has enough helium-3 to power the entire world for over 1,000 years. But why is there so much of helium-3 on the moon and barely none on our planet? Well, that's because helium-3 comes from the sun and travels in solar winds. Solar winds are like streams of dangerous particles. They're super radioactive. Our planet's thick atmosphere and magnetic field serve as a shield for us. They almost fully protect us from those particles. But, unfortunately, they also prevent the good stuff like helium-3 from getting here. The Moon's atmospheric shields are super thin though, so it's under a constant shower of solar winds. So, helium-3 accumulated there over billions of years, and now it's just scattered around there. But mining it and bringing back to Earth is no easy feat. It's super expensive. Just think about it. Rockets need tons of fuel to break free from gravity. Every single bolt and screw on the spacecraft must be engineered to survive extreme conditions, like radiation. Not to mention, you need a team of rocket scientists, literally working around the clock to make sure nothing goes wrong. You can't call a repair guy if something breaks on the Moon. So generally, it costs about $500,000 to send 1 pound of payload to our satellite. That's based on estimates from NASA. To get some idea, let's calculate how much it would cost to send an apple to the Moon. A typical apple weighs about 0.4 pounds, so that funny mission would be at least $200,000. Now, for comparison, the Chinese launch system weighs around 80 tons. Another problem is that the lunar surface is pretty harsh on the equipment, like the freakish lunar dust, for example. You might recall this small thing that happened in the 60s called the moon landings. But when the Apollo astronauts came back from the Moon, they found something weird was happening to them. Their throats were sore and their eyes wandered. Luckily, it wasn't some scary moon sickness. Turns out, there's a lot of lunar dust clinging to their spacesuits. This dust seems harmless, but it's made up of sharp and abrasive particles, much smaller than a human hair, yet sharp like glass. It contains silicate, a thing that can cause severe lung problems on Earth and is a common issue for miners. So it caused a lunar hay fever. At least that's how NASA astronaut Harrison Schmitt called it. All 12 astronauts who walked on the Moon were then sneezing and experiencing nasal congestion. Sometimes it took days to fade away. The dust even got inside their spacecraft, smelling like burnt gunpowder. This nasty stuff can be harmful to both humans and equipment. It managed to damage spacesuit boots and even ruin the seals on the containers used to bring back samples during the Apollo missions. As we mentioned, they're glass-sharp and jagged, so they start scratching, grinding, and wearing down any surfaces they come in contact with. They don't care if it's metal, glass, or humans. And since there's so much dust, this causes equipment to malfunction and fail quite quickly. And that's just one of the possible hurdles with lunar missions. So scientists really need to come up with some weird ideas to get that precious helium-3. The Chinese scientist project looks like a weird sci-fi invention, but it's a cost-effective way to transport materials back to us. It could throw stuff to Earth twice a day, and it would be 90% cheaper than current methods. Since it only needs electricity and no fuel, the system would be small and easy to set up. Besides the beloved helium-3, this catapult would also help advance technologies in space mining and heavy launch vehicles. No lunar dust scares this thing. It should last for at least 20 years. It would need to be transported to the Moon using China's super heavy lift rocket. But the idea is far from new. There was a novel called The Moon is a Harsh Mistress by Robert A. Heinlein. In the story, there's a lunar colony that uses an electromagnetic catapult to send weed and water ice back to Earth. It gets quite wild when the colonists, known as loonies, eventually take control of this catapult. They threaten to launch rocks at Earth unless their colony is recognized as an independent world. Sounds kind of funny, but a large rock, if thrown at us from the Moon, could wipe out a city. The damage would be like from a meteorite strike, with fires, houses destroyed, and worse. But scientists have been talking about this catapult idea for a while. For decades, they were trying to find a way to use electromagnetic systems to send resources from the Moon to Earth. There are also some challenges. For example, scientists forgot to mention how exactly helium-3 would be extracted from the lunar soil. Installing this launch system on the Moon's rugged surface would be difficult as well. Also, they would need to make sure that the system remains stable at high speeds and that it could withstand the Moon's extreme temperature changes, cosmic rays, and intense solar radiation. So, it would take some time to develop. China hopes to have the key components of the system ready by 2030. The full-scale operations might start by 2045. China has tons of plans for the moon. For example, they want to build a research station at its South Pole by 2035. But China's not the only one in this space race. Considering that NASA plans to send humans on Mars by that time, oh boy, the 2030s will be a crazy decade for space exploration. There's also an American startup that's part of the lunar economy. The ones that plan to land astronauts on the moon have people actually living on our satellite in a decade or two. One of the goals of this colony is to boost economic growth and create new jobs. Most of them will likely involve some mining activities. And if there'd be 2 space colonies, well, they'll have to figure something out.
Hey, look up! There's a meteor shower happening right now! Okay, not really. But I made you look. If you're a fan of full moons, there's one coming up very soon. On February 27th to be exact. I really hope this video comes out in time. The moon will be lit up right in front of our eyes because it will be located on the opposite side of the Earth, where the sun is. It will help illuminate the moon, providing us with a night to remember. Take a good look at it. Doesn't it sort of resemble a huge snowball just hanging from the sky? Some native tribes in the northern hemisphere of our planet might have thought the same. That's why they used to call it the snow moon. You know, when it was big and full, like this. Okay, go ahead and grab a telescope now, because on the 9th and 10th of March, there are 3 planets that will line up for your aesthetical pleasure. Starting from top to bottom, you'll see Jupiter, then Saturn, and last but surely not least, Mercury. Now, depending on how good your telescope is, and if you've even got one, chances are you'll see some details of these 3 planets. You adjust your telescope a bit, and there it is, another planet. Almost like they're not thousands and thousands of miles away from each other. But that's not all. They'll be visible to the unaided eye too. This means you won't even need a telescope. Well, you'll probably see them like this, 3 bright white balls in the sky. Still astonishing though. You'll need to be looking at the southeast around half an hour before the sun rises, and voila, there they are. In the mood for a relaxing shower? How about a meteor shower instead? This time, you can keep your telescope safely stored, and you don't need to worry if you miss 1 or 2 of these showers, as there are quite a few happening this year. They're pretty evenly spread out too, and I don't mean the meteors. Those come close together. Grab your calendar and put a reminder on these months. You can choose from April, August, October, November, and December. Some months even have 2 showers instead of only 1, like October and November. Choose the month and day that works for you. Just check your calendar again. If you don't mind it being a bit chilly, just wrap yourself up in a blanket and hop in the back of your pickup truck. Then, all you have to do is stare up and enjoy the sky all night long, waiting for the shower to happen. Or, if you like to work by the clock, set up an alarm to wake you up in the middle of the night. That works too. Mercury's coming right at you! Watch out! Don't fret. It's still right up there, just a bit closer than usual. That's because on the 17th of May, it'll be at its greatest eastern elongation. What this means is it will be easier to observe. Right after sunset, point your eyes to the skies in the west and try to look for the planet. This happens again during the 4th of July, but this time you'll have to look to the east. You might need a compass. Start your celebrations early in the morning, just before the sun rises, with a gorgeous view of Mercury, and of course a cup of coffee in your hand. If you still don't catch it then, try September 14th or October 25th. How about when the moon loses its natural white color? This happens just a few days after Mercury's first performance, on May 26th. It's called a total lunar eclipse. The moon will get gradually darker, as if someone was dropping dark red paint on it, until it finally reaches this sort of rusty red color that you can see on the screen. Not all of us will be able to see this unless you're on a cruise in the Pacific Ocean or in the calm fields of Eastern Asia. If you live next to the Tokyo Tower, you're in luck. It'll be visible throughout the whole of Japan. And if you happen to live in the western part of North America, you'll also be able to see the moon shapeshift. Well, not quite shapeshift. It's not going to turn into a wolf or anything. That only happens if you're a werewolf, which I definitely am not. So it's more like a color shift. Still, on the moon, picture a massive black hole. Well, this next astronomical event kind of resembles that. On June 10th, during the annular solar eclipse, the moon will be the furthest it ever gets from Earth. While it's doing this, it ends up covering most of the sun, leaving just a bit of its curvature for us to see. If you happen to look at the sky during this time, what you'll see is a massive ring of light. Chances are you won't be able to tell that's the moon out there, since it'll be the same color as deep space, the absence of color, or just a very deep black. Oh, and that ring you're seeing? That's the sunlight. Okay, since we're talking about rings, I've got one for you, Saturn's ring. This planet is the full package. It's a planet, it has a ring, and get ready for this, it has 82 moons. It feels like every year a few new ones pop up out of nowhere. Anyway, during August 2nd, the planet will be at its closest point to Earth, and the sun will help us catch a good sight of it by brightly illuminating it. Not only will it be brighter than it ever is during the whole year, but it will also be visible all night long. This is the time to get that telescope ready again. A medium-sized one should do the trick. That is, if you want to see its rings and some of its moons, the ones that shine the brightest. Another planet that's coming closer is Jupiter, this time on August 19th. The same thing that happened to Saturn will happen to it. The sun will shine bright on its big planet face. The only difference is that this time, if you have a good pair of binoculars lying around, you'll be able to see the planet's 4 largest moons. Although they'll look like tiny dots, but now you know what they really are. Okay, so you've been thinking about those meteor showers I mentioned earlier. Well, this one is the best there is. It's called the Perseids meteor shower, and it almost looks like the sky is a pitching machine, except it's pitching meteors. During this particular shower, you might even be able to observe up to 60 meteors per hour. They're very bright too. Look at them go! Zoom! There goes another one. The best days to get cozy, sit on the grass, and just lie there looking at the sky is during August 12th and 13th. Usually, when these 2 days come around, the sky's dark and clear, perfect for a meteor shower. Picture a slightly red moon. That's called the partial lunar eclipse, and it happens during the 19th of November. This same red moon will get darker and darker as it moves through Earth's shadow. It won't be visible to everyone though. Here's a globe. Let's mark the places where you can see this partial lunar eclipse. First, we got Eastern Eurasia, then Japan. The Pacific Ocean's included in this list too, but unless you got a boat, you're likely not going to be there. Then we've got North America, Mexico, Central America, and lastly, some parts of Western South Africa. Grab a hold of your eclipse glasses and get ready for this last one. It's the last solar eclipse of the year. This one in particular is the best one to catch, as the moon will block the sun for almost 2 minutes. You'll be able to see the almost ghost-like sun's corona, also known as its outer atmosphere. The sad part is, you'll have to be in Antarctica or the South Atlantic. Just be careful out there. I heard it gets a little chilly.
Now, Mercury is the planet that's usually closest to Earth. Does that surprise you? Did me. Venus certainly gets closer to us than Mercury. It can be as close as 25 million miles. After all, Venus is the second planet from the Sun, and Earth is the third. Even Mars gets closer to Earth than Mercury. The red planet can come as close to our home as 35 million miles, as it will in the year 2287. I won't be around for that. The average distance from Earth to Mercury is 48 million miles, but Mercury is still usually the closest planet to Earth. That's because Venus is usually somewhere on the other side of the Sun for 112 days, and Mars is usually far away in its highly elliptical, almost 2-year-long orbit. That leaves Mercury zipping between the Earth and the Sun every 44 days, and thus usually closer to Earth than either Venus or Mars. Hey, good trivia question to pull on your friends, isn't it? 22 spacecraft have successfully flown to Venus, and over 30 spacecraft have flown to Mars, but only 2 have ever gone to Mercury. So, what's so hard about going there? Well, it has to do with the Sun. Mercury is not only the planet that is usually closest to Earth, it is also the planet that is always closest to the Sun, 28.6 million miles close, to be precise. Being that close to the Sun creates navigational challenges, to put it mildly. Any spacecraft going to Mercury gets accelerated by the tremendous gravitational pull of the Sun. The spacecraft will be moving too fast to go into orbit around Mercury. That's why the first spacecraft that went to Mercury, the USA's Mariner 10, merely flew by Mercury 3 times, but made no attempt to achieve orbit around Mercury. The only other ship to go to Mercury, the USA's Messenger spacecraft, took 6.5 years to get there. Now that's a trip. Messenger did achieve orbit for a period of 4 years before finally running out of fuel and crashing onto the surface of Mercury on April 20, 2015. Many other spacecraft have flown to Jupiter in about the same time or less than it took Messenger to go to Mercury. The hang-up is the deceleration of the spacecraft. Quite simply, it takes too much onboard fuel supply to fire the engines in the reverse direction and brake the speed of the ship against the Sun's great gravity. Slowing down sufficiently to get into orbit around Mercury is a no-go using rocket power. Some other way had to be found to slow Messenger down, a way that didn't use much or any fuel. Messenger was a hefty 2,400 pounds or so, loaded with 9 pieces of state-of-the-art scientific equipment. Now, 55% of the total weight, or about 1,300 pounds, was fuel. But this fuel would not be used to slow the spacecraft down. The fuel would be used for 5 engine burns associated with gravity assists and also for orbital adjustments once Messenger got to Mercury. Now, gravity assists uses the gravity of a planet and the planet's orbital velocity to either speed up or slow down a spacecraft. If the ship approaches a planet at a forward-moving angle, that is, an angle in the direction the planet is revolving around the Sun, then both the planet's gravity and the orbital velocity of the planet give the spacecraft a slingshot boost, greatly increasing the speed of the craft and sending it off in a different direction. This boost in speed can be added to by the spacecraft firing its rocket engines at just the right time. Both of America's Voyager probes use Jupiter's massive gravity to slingshot them to the outer gas giant planets and eventually out of the solar system. Gravity assist can also be used to slow down a spacecraft, as in the case of Messenger. By entering a planet's orbital path ahead of the planet's gravity pulls back on the spacecraft and slows it down. An engine burn is necessary at this time to escape the orbital path of the planet. Messenger performed 1 gravity assist flyby of Earth, 2 gravity assist flybys of Venus, and 3 gravity flybys of Mercury. Only then had Messenger been slowed enough to enter into orbit around Mercury. The probe traveled an astounding 5 billion miles to get to Mercury from Earth. That's farther than Pluto is away from Earth at its most distant. The name Messenger is an acronym, almost as clever as its intricate flight path to Mercury. Because Mercury is the fastest-moving planet, the ancient Greeks appointed Mercury as the messenger of Olympus. News traveled fast even back then. Messenger really stands for Mercury Surface, Space Environment, Geochemistry, and Ranging. What do you think? Did they have a contest to come up with that? Now, the good news is, there's another mission to Mercury underway right now. It is a combined ESA-JAXA space mission that is bringing 2 orbiting satellites to Mercury. The mission doesn't use an acronym for its spacecraft, it has a real name, Bepi Colombo. No, it's not a cartoon character. Dr. Giuseppe Colombo, after whom the spacecraft is named, was an Italian mathematician and professor of applied mechanics. He worked with NASA on the Mariner 10 mission to Mercury. Bepi is Giuseppe's childhood nickname, which everyone knew and loved him by. NASA had been content with 1 flyby of Mercury, the first ever, But Professor Bepi calculated that with a slight adjustment of the flight path to enable a gravity assist at Venus, Mariner 10 could fly by Mercury again and again on different orbits around the Sun. Thanks to Bepi, NASA got 3 flybys of Mercury for the price of 1. Bepi-Colombo, the spacecraft, is scheduled to perform 9 gravity assist flybys, 1 at Earth, 2 at Venus, and 6 at Mercury itself. Each planetary deceleration slows Bepi-Colombo relative to the speed Mercury is moving around the Sun. This will allow for orbital insertion. Otherwise, Bepi-Colombo would head off into the Sun. Now, once in orbit around Mercury, Bepi-Colombo's Mercury Transfer Module, or MTM for short, will release 2 satellites, one European, the MPO, Mercury Planetary Orbiter, and one Japanese, the MEO, Mercury Magnetospheric Orbiter. Both are expected to orbit Mercury for 1 year. Altogether, the MCS, Mercury Composite Spacecraft, consists of the MPO, the MEO, the MTM, and MOSIF, which protects the spacecraft from the Sun and houses the electronics for MEO. This alphabet soup of mission components highlights the other reason it is difficult to get to Mercury. After 6 gravity assist slowdowns, 6 engine burns, 18 orbits around the Sun, 6.5 years of travel time, and 9 billion miles of distance, you have to bring a tailored complex of equipment. It's like that mountain picnic you'd like to go on. You can't just drive there. You have to hike a long way up a tricky mountain trail and bring along insect repellent, sunscreen, and your hat. Oh, and lunch and beverages. It's not easy. Bepi-Colombo has packed it all, including lunch. Nah, not really. The design is incredibly complex. Nothing can face the Sun, not even the solar panels. The solar panels must be kept turned almost to a right angle to the Sun, or the heat and particle flux will corrode the solar cells, and without electricity, you have nothing. Therefore, at right angles to the Sun, the solar panels must be extra long, as if there were only a little bit of sunshine. Bepi's solar panels are 50 feet long. The sun shield must remain gyroscopically aligned towards the Sun so that all instruments are always in the shade but still have a line of sight to what each is meant to monitor. And there are a lot of instruments, 5 in the JAXA orbiter and 11 in the ESA orbiter. It's one amazing picnic. Anyway, the science objectives are meant to add to what we have learned from the previous 2 missions to Mercury. The data collected by Bepi-Colombo will enable scientists to study the planet's interior and composition, along with Mercury's geology and surface morphology, Mercury's magnetic fields formation and evolutionary history, the planet's solar wind interactions, and overall environment. As a metal-rich planet, Mercury may hold a vast wealth of minerals that MESSENGER failed to detect. Bepi-Colombo launched in October 2018 and still has a long way to go before it goes into orbit around Mercury. However, Bepi has already flown past Mercury and returned new photographs. The European Space Agency is excited about its first hot mission. All of the ESA's previous missions have been cold missions to objects further out into space, such as Mars, the asteroid belt, Comet Rendezvous, and elsewhere far out in the solar system. Well, all I can say is, best wishes to Bepi-Colombo. Let's hope all goes well on its 800 degrees Fahrenheit mission to Mercury. Let's hope that Mercury's long tail of exosphere gases, sodium, magnesium, and potassium, blown off the planet's surface by the solar wind, don't fog up the lenses or coat the solar panels. Have a nice time! Ciao, baby! The only life that we are certain about so far in the entire universe is on planet Earth. Whether that life is intelligent is, let's say, arguable. But anyway, it's not surprising that we're tirelessly searching for life on other planets. So far, they've discovered more than 4,000 of them. But what's even cooler, NASA has compiled a new list of 24 planets that aren't just Earth-like, they're better. The conditions on them are so good that they're more comfortable than on our planet. So let's examine some of them. KOI 5715.01. Let's be coy, shall we? This wonderful planet is in the constellation Cygnus. And why is it so wonderful? Well, our sun is a yellow dwarf. And sorry, sun, even though you're not bad at supporting life, there are some stars that can do it better. Nothing personal. The planet Koi 5715.01 orbits near an orange dwarf. Orange dwarfs are stars slightly smaller than our sun and have a little lower luminosity. Did you like the alliteration there? Anyway, don't worry, it doesn't mean we're going to live in complete darkness. In fact, if the planet is found closer to the sun and it has a thicker atmosphere, it may even be lighter and more colorful than on Earth. Now, our sun has a very short lifespan. Right now, it has 7 to 8 billion years left to live, a little longer than Earth's age. But orange dwarfs can live from 45 to 70 billion years. This is great not only because we'll be able to hang out on this planet longer, but also because the planets around these stars have more time to form life. Now, ideally, we would need to find a planet next to an orange dwarf that is about 7 billion years old. It's very likely there will be at least some organisms there. Koi 5715.01 is about 5.5 billion years old. Yeah, it may not seem mature enough, but that's okay, neither do I. Our Earth is a billion years younger, and that didn't stop us. The planet is quite close to its star and is in a habitable zone. 1 year there lasts 190 days. Imagine going to elementary school and already getting a driver's license. It's almost 2 times larger than the Earth. The average temperature there is 52 degrees Fahrenheit, which is slightly less than ours, 57. But it mostly feels warmer there because strong gravity helps it hold on to heat in the atmosphere longer. It's a little too far away though, like 3,000 light-years from Earth, which is about 18 quadrillion miles. Yep, better bring a really big lunch with you. Koi 3010.01. This planet is found next to the star Koi 2010. This planet sounds like a very pleasant world. The average temperature on this planet is 67 degrees, so a little warmer than ours. But that's a good thing. Scientists believe that on a perfect planet, the temperature should be just about 10 degrees hotter than on Earth. The more heat there is on the planet, the more comfortable it is to live there. Also, the higher chances of developing life. The radius of this planet is nearly 1.5 times larger than Earth. There's some atmosphere, although we're not yet sure about its composition, but it's probably like the Earth's. Scientists think that we'll find an ocean there, and it can cover up to 60% of the surface, which is also cool. In a perfect world, water and land should be distributed more evenly than on our planet. A little more land means a little more territory and resources, right? But listen, this planet is actually very similar to the Earth. The semblance is so striking that scientists believe we have an 84% chance to find life there. Of course, not necessarily an intelligent life, but at least some animals. Wouldn't that be cool? Now, what do you think they could look like? Very Earth-like planet, but with stronger gravity. Well, if someone lives there, they're probably big but have a small height and strong little legs. Sounds adorable and scary. But we won't be able to find out the truth anytime soon. So far, for us, these planets are microscopic dots in space. We only have some dry, boring data about them and don't even know what they look like. We'll have to wait until we can find a way to get closer to these planets. Kepler 186f. This is also one of the best candidates for having life. This rather cute planet was nicknamed the Earth's cousin because it does have a strong resemblance. Anyway, these two planets are like sisters, not twins. Kepler 186f rotates near a red dwarf. Red dwarfs are stars even dimmer and smaller than orange dwarfs. Yeah, they'll also live for a very, very long time, but their luminosity is also quite low. However, Kepler 186f is closer to its star than we're to our Sun, so it shouldn't be too dark there. Well, at least not night-like dark. The sky on this planet is sure to be an unusual shade of red, like sunsets on Earth. What do you think? Would you like to live on a planet with an eternal sunset? The size of this planet is about the same as Earth. Not bad, not perfect. Why so? Because the coolest planets are those that are bigger than Earth and have stronger gravity. Now you'll probably say, but wouldn't it be harder to walk there and even harder to get out of bed on Monday? Of course. But on the other hand, this planet will pull the atmosphere better. The atmosphere will be thicker and denser. This means more protection from the scary space stuff, more oxygen, and more heat. Not to mention the fact that the bigger planets have more space to settle. Awesome, right? But of course, the Earth's size is also an excellent choice. Another cool fact is that the tilt of Kepler 186f is about the same as ours. It means that there should be stable seasons and a normal day-night cycle. Do you know how important the tilt of the planet is? Let's look at Mars. Mars is also, in fact, found in the habitable zone of our Sun, but its tilt is very unstable, and as a result, the entire ocean that could have been on it once now completely dried up. Today, it's just a red desert, and there's no life there. At least not as far as we know, but you see how important these tiny details are? This planet is also quite far away from us, 490 light-years. That's about 3 quadrillion miles. So yeah, we're just going to keep waiting for intergalactic travel. Kepler 62e and 62f. These planets were called the most Earth-like before we discovered Kepler 186f. They're very comparable to our home. Kepler 62e is about 1.5 times larger than Earth, and Kepler 62f is just slightly smaller than that. They're located in the constellation Lyra, which is about 1,200 light-years away from us. They both also orbit a red dwarf. 1 year on Kepler 62e lasts about 122 days, even less than on that first planet we talked about. Scientists believe that both 62e and 62f are sort of water worlds, warm places mostly, or even completely covered with water. If there is land there, it's probably just some islands. A world consisting entirely of islands. A fantasy dream for some, think Hawaii, and a nightmare for others, think Megalodon. But if you're a fan of ancient marine animals, just imagine how gigantic they could be there. Still, there are many things we don't know about this planet. Does it have a surface? What about its composition, density? One day, maybe we'll be able to answer these questions. And so, that's it for the super Earths. Of course, the original list is much longer, and you can go check it out on the internet. Now, the best thing about all this is that these are planets that are better than the Earth. But we also know thousands of other exoplanets that are just close enough to ours. And the odds are, a few of them have at least some form of life. But they're very, very far away, so we have no way to check it out right now. Perhaps, down the road, we'll find some cool creatures on many of them.